So we just saved our team $33,000 a year. It was about 240 hours a year or 20 hours a month that we had manual labor that was going into building our images. And we saved this all with infrastructure as code. It took like 2 to 3 days of development. So I'm going to go through the exact process we went through so that hopefully you can implement something similar for your own business. So the problem we're facing is manual image builds. I work in a large managed service provider where we manage the platform basically where we provide servers for other teams to build their applications on. Those are our customers. So we manage the operating system, the storage, the hypervisor if it's on-prem, usually in the cloud though. And so each month we had someone, engineer going in and building a new golden image so that that would be the baseline for what our servers are built on. So they'd go into a fresh, say, rel instance, and then they'd run an Ansible playbook. They might have to add some storage, run the playbook. It takes like 2-ish hours for each of them, and then they convert it to an image template, and that's our new image template for the month. So that way it was patched fresh and we had a new image every single time. But the problem is with AWS, it's pretty easy. You can share across the organization, which we have a lot of accounts in there. So it's 2 hours a month. That's still not great, but at least they do it once and then it's shared all the way across. With Azure, though, we had to do that in every single subscription we have, which we have a lot of them. And so it's like 2 to 3 hours, but then every single subscription, they had to do the same thing, start from scratch. They'd create an image, add the storage, run the Ansible playbook, make sure everything goes successfully, because if there's errors, they're now debugging. So it was just very repetitive process that we need to do it for our security and compliance to make sure things are up to date. And it also saves build time, but at the end of the day, it's just someone doing the same thing every single month, and it's kind of wasted money in that sense. And then the other major problem here is that we had no way to track the change across the builds. So we would start with our base RL build, and then we run the Ansible playbook to get to here, where we now have all of our configuration changes in there. But each time they were starting with the REL build that already existed rather than a fresh REL instance. So that means that if I wanted to be malicious, or if I just didn't know what I was doing and I went in and changed something with, say, the DNS server that we're using or changing the storage layout, like I could go make that change manually on the golden image, save that. Nobody would know. And then now every build for indefinite in the future will have that same change. Whereas what we did now, which we'll get into with infrastructure as code, is we start from a base rel instance every single time and we build all the way through each month with the latest rel instance so that way we know exactly what's in there and it has to be in the code for it to get into our golden image. Okay, so how did we do this? The main two things here are Packer and Terraform. So if you're not familiar, these are both HashiCorp tools. Packer is for automated image creation using code templates. So here's their site. You can actually see in their use cases, automated image builds and golden image pipeline. This is what we're doing here. So this is just a way that we can configure our build as code, and then we can move it into our paths in a very seamless way. And so here's what Packer might look like. So we define the required plugins, which if you're familiar with HCL, which is HashiCorp language, and you'll know kind of what this looks like. We define a source. So this one is saying that we're going to do a Docker for Ubuntu, and then we define our build. And so this would be called Learn Packer, and it's going to use this source. And then inside of this build block, you can actually use provisioners. So we already were using Ansible, so it was so easy because I basically just created an Ansible provisioner that ran the playbook that we already had. So it did not take long because of that. It was just where are we shifting it in the process? So rather than create the image and then run the playbook, we were going to create our base image, run the playbook, and then have an image from that. So it's just moving it left, and then that way it's now baked into every single build rather than running after. So for example, when a customer came to request an application, or a server rather, they would come in, they'd request it, whatever configuration they need, and then we'd run our Ansible playbook to make sure it's up to date. Whereas now we can run the playbook beforehand, create an image, and then it has a much shorter process just to do the kind of customization that they need to that image and not all of the base build. And then Terraform, we were already using this actually. They were just manually referencing the build that we were creating, or rather referencing the build that we created manually. So with Terraform, you can actually create a data block and you can use the name. So if we had our Packer deployment as our name of our image, we can just use those data blocks to automatically pull the latest. So we say, hey, go find the latest image that is called Packer build and then it pulls that out. We get the AMI ID and we insert that directly to our build. So now every time we build, it's just going to pull the latest. And that way we have two streamlined processes that are also separate from one another. So we have our Packer build that every single month we're going to build a new image out. And then Terraform will just automatically pull out whatever the latest image is with that same name. And so that way we can set this up for RHEL 8 and RHEL 9, which is what we're running. And then the automation side, so we use GitLab pipelines here. So we effectively create a pipeline for every single build we need. So there are multiple government, commercial, kind of all different kinds of accounts we're doing on both AWS and Azure. And so we create these pipelines, just give it the authentication that it needs, and then it builds in all of those environments on a schedule. So that way it is completely hands off. I will get an email if something fails, and otherwise we just know it's working and it's building every month without us doing a single thing now. And then version control, so everything is now tracked in Git. We have our image build pipeline, which is how we actually provision it with Packer. We have our Terraform that manages how we deploy it. And then our Ansible script that we use to actually configure the VM when we create it, that was already in Git as well. And that's what we pull into the system to be built from. So you cannot make a change to our build pipeline unless it goes in Git. If you do, the next month, it will just be deleted. So the key benefits here, I've kind of alluded to some of these. The consistency that we get now, we know every single build is the same. We're building it with Packer and Ansible, and every time it's all the same code. So there can't be a change. And so this has helped to kind of alleviate some of that, like it's working in dev, but not in prod, or it's working in this account, not this account. It's just everything is on the same page. If it doesn't work in one spot, it's broken in dev, and we can catch that before we ever merge it into our prod. Next up, speed. So like I said, we had about 20 hours a month. Perfect definition of toil here. It is just like repetitive work that was not providing value to the organization, but we had to do it to maintain. So this way we were able to completely automate it away. And now it's just, we handle the errors. We don't have to actually do this work every month. Reliability, way less manual errors. As you can imagine, if you're building the same image 20 times in 20 different accounts and it's the exact same process, sure, you might get good at it, but you also get lazy. You don't want to sit there and type in the same commands and just follow a checklist. And so you might either try to cut corners on purpose or just like not be paying attention because you've done it 10 times already and you're on the 11th go and you make a stupid error and you don't catch it and then it wastes even more time. And then the last thing, that traceability. So this is really the core of infrastructure as code. We want to make sure that everything is moved into Git. This is often with like traditional sysadmin teams, which is what we have. That hasn't been trained as much as in like a software engineering role. So making sure that we have everything in Git, we can roll back as needed. And it also allows other people when they're getting onboarded to see exactly what exists. So the results for our team, $33,000 a year in labor savings. So now our engineers can actually work on the things that are improving the systems and the process that we're doing rather than doing this manual toil. Build time. So this is directly to our customers. When a customer requests a server, how quickly do they get that server? It increased by 50% because some of our applications, or some of our images rather, were falling behind where we weren't keeping them patched as late. And we could do daily builds now of these images if we wanted. And that way we know that all of the latest patches are in there and we don't have to do that at build time. We can do it at the image creation time. So that was the longest part of our deployment process with our platform as a service. And it reduced the whole build time by 50% because of this. And again, 3 days of work. So I spent about 20 to 24 hours building this process out, and it's now going to save 20 hours a month. So that's a 12x multiple if you average it out over the year. And that's just for 1 year. And so there are probably a lot of these things within your organization that you either don't know exist or don't have the time to put into. And it's really just about identifying what's the highest leverage activity for you to be doing. So go find something like this that can be automated or search for other ways. Like if you're not using infrastructure as code, that's usually the lowest hanging fruit. You could do this. This is on the virtual machine layer, but if you're working with containers, you could use Docker. You probably are if you're using containers, but still the idea of like, you want to make sure as much of that like one-time build process is built in before it gets distributed instead of create a base image, distribute, and then build on top of it. You want to create the base, build on the base, and then distribute so that it's all one source of truth. So then lastly, the next steps. If you found this video helpful, be sure to subscribe. And if you happen to run a cloud team currently and you're looking to get started with infrastructure as code or identify some of those high leverage points, go ahead and book a call with me, link in description. And otherwise, thanks for watching.